For decades, getting data from one place to another inside a big company has felt a bit like navigating rush hour traffic. Imagine you have a vital piece of information, say, a customer's latest purchase, stored in one system, but your analytics team needs it in another to spot a new trend. The journey isn't a direct one. Instead, the data has to be picked up, driven to a workshop to be reformatted, and then finally dropped off at its destination. This cumbersome three-step process is known in the industry as ETL, which stands for extract, transform, and load. It was a clever solution for its time, but it's beginning to show its age in our fast-paced world. The first step, extract, is like sending a courier to collect a package of data from its source. The second, transform, is where the real work happens. Data rarely comes in a neat, tidy format ready for analysis. It needs to be cleaned, standardized, and sometimes reshaped entirely so that the destination system can understand it. Think of it as translating a document from one language to another. Finally, the load step involves delivering this newly polished data into its final home, often a data warehouse, where analysts can get to work. While this sounds straightforward enough, the entire process is surprisingly slow and clunky, often running in batches overnight or even just once a week. This built-in delay is one of the biggest drawbacks of the traditional ETL model. In a world where business decisions need to be made in minutes, not days, waiting for data to complete its nightly journey is a significant handicap. By the time an insight is uncovered, the opportunity to act on it might have already passed. A retailer might miss the chance to restock a popular item before it sells out. Or a bank's fraud detection system might only flag a suspicious transaction hours after it has already gone through. The lag created by batch processing means businesses are always looking in the rearview mirror, making decisions based on what happened yesterday, instead of what is happening right now. On top of the time delay, these old data pipelines are incredibly expensive and difficult to maintain. Each one is a custom-built piece of digital plumbing that requires a team of skilled data engineers to construct and then constantly monitor. As a company grows and adds new data sources and applications, the network of pipelines becomes a tangled, brittle mess. A small change in one system can cause a cascade of failures downstream, leading to frantic late-night troubleshooting sessions. This complexity not only drains resources and budget, but also creates a bottleneck where business teams have to get in a long queue just to request a new data connection. What if we could eliminate the traffic jams? What if data could move from one system to another instantly, without the complicated detours for transformation and loading? This is the promise of a new approach that is rapidly gaining momentum: Zero-ETL. The name says it all. It's a vision for a world where the cumbersome, multi-step ETL process simply disappears. Instead of building and managing elaborate pipelines to move data around, Zero-ETL architecture allows data to be shared and accessed in near real time, directly from its source. It's like teleportation for your data, making it available wherever it's needed, the moment it's created. The core idea behind Zero-ETL is to decouple data from the application where it lives. In the past, data was locked away inside databases tied to specific software. To use that data elsewhere, you had to perform the whole ETL ritual. Zero-ETL flips this on its head. It creates a seamless fabric where data generated in one place, like a transactional database on Amazon Web Services, can be instantly queried and used by an analytics platform running on a completely different cloud, like Microsoft Azure or Google Cloud. The physical location of the data and the underlying technology become irrelevant, breaking down the silos that have plagued businesses for years. This isn't just a minor improvement, it's a fundamental shift in how we think about data architecture. The traditional model was built around the idea of copying and moving data. You had your source of truth and then numerous copies of it scattered across different systems, each one slightly out of date. Zero-ETL moves us towards a model of direct access and sharing. Instead of making endless copies, you grant secure access to the live original dataset. This ensures that everyone, from the data scientist training an AI model to the business executive viewing a dashboard, is working with the exact same, up-to-the-minute information. The implications of this shift are profound. It means that the long, frustrating wait for data is over. It means that the vast, expensive infrastructure built solely to shuttle data from point A to point B can be retired. And it means that the brilliant data engineers who spent their days fixing broken pipelines can now focus their talents on more valuable work, like building the next generation of data-driven products and services. Zero-ETL isn't just about making things faster. It's about making them simpler, cheaper, and smarter, paving the way for a new era of business agility. The concept of instantaneous data sharing might sound like a bit of technological wizardry, but the mechanisms that power Zero-ETL are quite clever and grounded in established technologies. One of the key enablers is a technique called change data capture, or CDC. Imagine your main database as a ledger book, where every new transaction or update is recorded. Instead of periodically copying the entire book, CDC acts like a vigilant clerk who watches for new entries in real time. As soon as a change is made, a new sale is recorded, a customer updates their address, CDC captures that specific change and immediately sends it to any connected system that needs to know about it. This process is incredibly efficient because it deals only with what has changed, not the entire dataset. It's the difference between sending a one-line text message to say you're running late versus resending the entire history of your conversation every time. By streaming these small incremental updates, CDC ensures that target systems, like a data warehouse or an AI platform, remain perfectly in sync with the source system, with a lag of seconds rather than hours or days. This continuous flow of information is what makes real-time analytics and decision-making possible, turning static reports into living, breathing dashboards that reflect the business as it operates moment to moment. Another crucial piece of the puzzle is the use of modern APIs, or application programming interfaces. Think of an API as a universal translator and waiter combined. It provides a standardized way for different software systems to talk to each other and request information, regardless of how they were built or where they are running. In a Zero-ETL world, a source system can expose its data through a secure API. An analytics tool can then simply call this API to request the data it needs, on demand. This eliminates the need for a middleman to extract and reformat the data, as the API handles the communication directly and delivers the data in a ready-to-use format. By combining technologies like CDC and APIs, Zero-ETL effectively creates a live, queryable data layer across the entire organization. It means that data doesn't have to be physically moved to be used. An analyst in London using a Snowflake data warehouse on Azure can run a query that securely accesses live inventory data from a transactional database running on AWS in Tokyo. The complexity of crossing cloud boundaries and integrating different systems is handled seamlessly in the background. This architectural elegance is the secret behind the zero in Zero-ETL. The goal is to reduce the effort, the cost, and the latency of data integration to as close to zero as possible. The most immediate and obvious benefit of adopting a Zero-ETL approach is the dramatic reduction in data latency. We've moved from a world where data is hours or even days old to one where it is seconds fresh. This isn't just about making reports run faster. It's about enabling entirely new capabilities for a business. A company can now react to changing market conditions, customer behavior, or operational issues in near real time. This newfound speed translates directly into a competitive advantage. It's the ability to spot and stop a fraudulent transaction as it happens, not after the money is gone, or to offer a customer a personalized promotion based on the item they just added to their online shopping cart. Beyond speed, the second major win is a radical simplification of a company's data architecture. The tangled web of brittle, custom-coded ETL pipelines that data engineers spent so much time building and maintaining can be dismantled. In its place comes a much cleaner, more manageable system based on direct governed sharing. This has a massive impact on operational efficiency. Data engineering teams are liberated from the thankless reactive work of keeping the lights on for data pipelines. Instead of spending their days troubleshooting failures and managing backlogs, they can focus their expertise on higher value activities, like developing new data models, optimizing queries, and collaborating with business teams to unlock new insights from the data. This simplification and increased efficiency naturally lead to the third major benefit: significant cost reduction. The costs associated with traditional ETL are multifaceted. There are the infrastructure costs of running the servers that perform the extraction, transformation, and loading jobs. There are the software licensing costs for the ETL tools themselves. And, most significantly, there are the immense labor costs tied to the teams of engineers required to manage this complex ecosystem. Zero-ETL slashes costs across all these fronts by eliminating the need for a separate ETL infrastructure and dramatically reducing the manual effort required to make data available for use. Furthermore, there's a hidden cost in multi-cloud environments that Zero-ETL directly addresses: egress fees. These are the charges that cloud providers levy whenever data is moved out of their network. For companies operating across multiple clouds, a very common scenario today, these fees can be exorbitant, sometimes accounting for the majority of data transfer costs. By enabling data to be queried in place or shared through optimized replication strategies, Zero-ETL minimizes the volume of raw data that needs to be moved across cloud boundaries. This directly translates into huge savings, making it financially viable to build a truly global, multi-cloud data strategy without the fear of a crippling bill at the end of the month. The theoretical benefits of Zero-ETL become much clearer when we look at how it's being applied in different industries today. In banking and financial services, for instance, the fight against fraud is a constant, high-stakes battle. Traditional systems that rely on batch data analysis might only detect a suspicious pattern of transactions hours after they've occurred. With Zero-ETL, transactional data from ATM withdrawals, credit card swipes, and online payments can be streamed directly into a fraud detection engine in real time. This allows algorithms to spot anomalies and block fraudulent activity within seconds, saving the bank and its customers from potentially huge losses, while also improving risk management and compliance reporting. In the fast-moving world of retail and e-commerce, inventory management is everything. A customer seeing an out-of-stock message is a lost sale. Zero-ETL allows for the creation of a single, unified view of inventory across all channels: physical stores, warehouses, and online platforms. When an item is sold in a London shop, the central inventory system can be updated instantly, making that data immediately available to the e-commerce site serving a customer in New York. This enables accurate, real-time stock levels, prevents overselling, and powers sophisticated supply chain optimization, ensuring products are in the right place at the right time to meet customer demand. Healthcare is another sector where timely access to data can have life-altering consequences. Imagine a patient being rushed to an emergency room. Their medical history, allergies, and recent test results might be stored in different systems across various clinics or hospitals. With a Zero-ETL framework, a doctor could securely access a complete, up-to-the-minute view of that patient's health record directly on a tablet. This provides the critical information needed for immediate and accurate diagnosis and treatment, rather than relying on fragmented, out-of-date records. This same principle applies to medical research, where scientists can analyze live, anonymized patient data to accelerate the discovery of new treatments and therapies. Finally, consider the manufacturing industry, which is being transformed by the Internet of Things, or IoT. Modern factories are filled with sensors on machinery, production lines, and robotic arms, all generating a constant stream of data. Using Zero-ETL, this IoT data can be streamed directly from the factory floor to cloud-based analytics platforms. Engineers can then use this live data to monitor equipment health, predict when a machine is likely to fail, and schedule maintenance proactively. This practice, known as predictive maintenance, prevents costly, unplanned downtime and keeps production lines running smoothly, boosting efficiency and output across the entire manufacturing process. One of the biggest and often unforeseen challenges of working with data across multiple cloud providers is the cost of moving it. Cloud providers like AWS, Azure, and Google Cloud make it very easy and cheap to get your data into their platforms, but they charge significant fees, known as egress costs, every time you move that data out. For a global company that wants to share data from its primary cloud in North America with teams or customers in Europe or Asia, these egress fees can quickly spiral out of control. This financial penalty has been a major barrier to building truly flexible, multi-cloud data strategies, effectively locking companies into a single provider. This is precisely the problem that new innovations in the Zero-ETL space are designed to solve. Take, for example, the Egress Cost Optimizer, or ECO, recently introduced by Snowflake. This feature is a brilliant piece of financial and technical engineering. Instead of a data provider repeatedly paying egress fees every time a consumer in a different cloud or region accesses their data, ECO changes the model. The provider moves the data just once to a secure third-party cache. From that central point, it can be shared with any number of consumers in any other cloud or region with zero additional egress fees for the provider. It's a move once, share infinitely model. The impact of a solution like this is staggering. According to Snowflake, this approach can reduce a company's egress costs by up to 96%. This isn't just an incremental saving, it fundamentally changes the economics of global data sharing. A software company that sells a data product, for example, can now offer it to customers on any cloud platform in any part of the world, without having to worry about unpredictable and sky-high data transfer bills. This makes it possible to serve a global market at a predictable cost, opening up new revenue streams and business models that were previously financially impractical. This focus on cost optimization is a critical component of the broader Zero-ETL philosophy. The goal is not just to make data sharing faster, but also to make it economically sustainable at a massive scale. By intelligently routing data and minimizing redundant transfers, these new tools are removing the financial friction that has held back true data collaboration. It means that decisions about where to run applications and where to store data can be based on what makes the most business sense, not on which choice will avoid the steepest egress penalties. This liberation from cost constraints is just as important as the technological liberation from ETL pipelines. For the Zero-ETL vision to truly succeed, it cannot be locked into a single company's proprietary ecosystem. The dream is to have data flow freely and securely between any system, regardless of who built it. This is where the growing adoption of open table formats comes into play. Think of formats like Apache Iceberg and Delta Lake as being like the universal shipping container of the data world. Before shipping containers, loading a ship was a chaotic, inefficient process with goods of all shapes and sizes. The standardized container made logistics incredibly efficient. Similarly, open table formats provide a standard way to structure and manage large datasets. When data is stored in an open format like Iceberg, it can be read and understood by a wide variety of different tools and platforms. A dataset created by the Spark processing engine can be read directly by a Snowflake data warehouse, which can be read by a Trino query engine, and so on. This interoperability is a game changer. It means you are no longer locked into a single vendor's technology stack. You can choose the best tool for the job at every stage of your data's lifecycle without having to go through painful and costly data conversion projects. It's a crucial step towards a more open and collaborative data landscape. Zero-ETL solutions are increasingly being built to embrace these open standards. For example, some platforms now allow you to share data that is stored in an open format like Iceberg or Delta Lake directly, without ever having to move or import it into a proprietary system first. An organization can maintain its own data lakehouse, built on open-source technology, and still use a commercial data platform to securely share that data with partners and customers. This gives companies the ultimate flexibility and control over their data assets, preventing vendor lock-in and future-proofing their data architecture for whatever new technologies may emerge. Another critical innovation that complements this open approach is the rise of secure data clean rooms. These are neutral, highly secure environments where two or more organizations can bring their data together for joint analysis without either side having to expose their raw, sensitive information to the other. For example, a retailer and a consumer goods company could analyze their combined sales data to understand the impact of an advertising campaign, but neither company would ever see the other's customer-level data. This privacy-preserving technology, often powered by Zero-ETL principles, unlocks powerful collaboration opportunities that were previously impossible due to privacy and competitive concerns, further breaking down the walls that keep data isolated. The shift to Zero-ETL is more than just a technological upgrade. It fundamentally changes the day-to-day lives and roles of data professionals. For years, many of our brightest data engineers have been bogged down in what can only be described as digital plumbing. Their days were consumed by writing complex scripts, monitoring batch jobs that often failed in the middle of the night, and troubleshooting the fragile connections that moved data from one silo to another. While essential, this work was often repetitive, reactive, and far removed from the strategic goals of the business. It was a constant battle just to keep the data flowing, leaving little time for innovation. With Zero-ETL automating the movement of data, these talented engineers are finally being freed from the boiler room. The focus of their role is shifting upwards, from data logistics to data architecture and value creation. Instead of being pipeline builders, they are becoming data product managers. Their time can now be spent designing robust, scalable data models, building curated data sets that are easy for the business to consume, and developing platforms that empower others to find the insights they need. They can now think strategically about how to best leverage the organization's data assets, rather than just worrying about how to move bytes from point A to point B. This liberation has a ripple effect across the entire data team. Data analysts and data scientists, who previously had to wait days for the data they requested, now have instant access to live information. This dramatically shortens the time to insight. An analyst can now explore a hypothesis, test it against real-time data, and share their findings with decision makers within the same day. This creates a much more dynamic and iterative workflow, where data exploration is encouraged and curiosity can be satisfied almost instantly. It transforms the data analyst from a historian who reports on the past into a navigator who helps steer the business in the present. Ultimately, this shift makes data careers more rewarding and impactful. By removing the tedious, low-value tasks that cause so much frustration, Zero-ETL allows data professionals to focus on what they do best: solving complex problems and turning raw data into meaningful intelligence. It elevates their role within the organization from a back-office support function to a strategic business partner. This not only improves job satisfaction and helps retain top talent, but also ensures that the organization as a whole is getting the maximum possible value from both its data and the brilliant people it hires to manage it. As we stand here in late 2025, it's clear that the move towards Zero-ETL is not just a fleeting trend, but a fundamental reshaping of the data landscape. We are at an inflection point, moving away from the rigid, slow, and costly paradigms of the past and into a future defined by instant, seamless, and cost-effective data access. The traditional ETL market, while still large, is facing a paradigm shift. The conversation is no longer about how to build better pipelines, It's about how to eliminate them entirely. The demand for real-time analytics, AI-driven insights, and collaborative data ecosystems is simply too strong for the old batch processing model to keep up. The innovations we're seeing today, from intelligent egress cost optimizers to the embrace of open table formats and secure data clean rooms, are just the beginning. The next wave of development will likely focus on making this technology even more accessible and autonomous. We can imagine a future where AI-powered governance tools automatically manage data access policies, where data contracts are standardized across industries, and where setting up a secure cross-cloud data share is as simple as sending an email. The goal is to make data integration so seamless that it becomes invisible, allowing people to focus solely on the questions they want to ask of the data. This future will have a profound impact on how businesses operate and compete. Companies that embrace this new model will be more agile, more efficient, and more innovative. They will be able to build smarter products, create more personalized customer experiences, and react to market shifts with a speed their competitors cannot match. Data will cease to be a resource that is hoarded in isolated silos and will become a shared utility, flowing like electricity to wherever it is needed to power new ideas and drive better decisions. This will level the playing field, allowing smaller, more nimble companies to leverage data in ways that were once only possible for the largest enterprises. In the end, the story of Zero-ETL is a story of removing friction. It's about breaking down the technical, financial, and organizational barriers that have prevented us from realizing the full potential of our data. For decades, we have been building walls around our information. Now, we are learning how to build bridges. The road ahead is one of increasing connection, collaboration, and speed. As these principles become the new standard for data integration, they won't just change our technology stacks, they will fundamentally change the way we work, the way we innovate, and the way we understand the world around us.